the underpinnings of the platform is what really helped. It helped Comcast save millions in operational cost. The system provided the ability to quickly identify issues that are long running, as well as new issues that popped up. And that really helped to reduce that overall failure rate to under 1%.
Portworx with Pure has allowed us to reduce that, so that's 1 monthly upgrade on a single instance of the database and the application versus 50 previously. So that was typically about 400 man hours a month to do that upgrade, is now down to 4 hours a month. And it's starting to shrink because we're able to do it even faster.
We started Kubernetes, I think we started in our cloud native journey or transformation way back in 2017. Our Kubernetes journey was always tethered around stateful stuff. State has been an important part. Storage is the key integral part, and I think there's hardly anything we can do in Kubernetes without having storage, and that is what is brought us together. Still a lot of problems to solve, and hoping to actually make it simpler and easier for everybody going forward.
Thank you for joining us for this webinar. I'm Eric Shanks. I'm a Principal Technical Marketing Manager, and I'll be your host today for our webinar. We're going to be talking about how Portworx by Pure Storage built our own internal developer platform. But I am not the star of today's show. The stars of today's show are both Rajan and Charu. Rajan, would you like to introduce yourself? Tell us a little bit about
Thank you, Eric, and really excited to be here. Great to meet everybody. My name is Rajan. I'm the engineering director at Portworx by Pure Storage. My team and I, we are responsible for releasing the Portworx line of products with high quality. So I oversee quality engineering, DevOps, and infrastructure services, as well as DevSecOps. A little bit about me. I've been with the Pure team for a little over 3 years now, and it's been a really fun ride.
Thanks, Rajan. And Charu?
Hey folks, myself Charudat. I've been working with Rajan, and I'm the architect for the DevOps and the engineering team for the Portworx organization. Pretty much been working on engineering efficiency from the last 7 years, and excited for this talk.
Thank you, Charu. We also have Jessica Christensen that is helping us backstage with some things around question and answers. Just wanted to give a shout to her. Thank you for all you've done to get this webinar up and running. Speaking of questions and answers, we expect to have time at the end of this session for you to present your own questions to the team. And if you want to do that, make sure that you post those in the Q&A section of the webinar. Without further ado, let's go ahead and get started. It might make sense for us to give you a little bit of background about what Portworx does so you can understand why we needed an IDP in the first place, right? So Portworx is a software company that focuses on providing container data management for Kubernetes. So we've got 3 main product lines. The first one being Portworx Enterprise, our flagship product. And what it is software-defined storage that lives in your Kubernetes cluster so that it gives you enterprise capabilities that you would typically get from like a hardware storage array. We give that to you in software, and it's baked directly into Kubernetes and is meant directly for containers in Kubernetes. Since we're all about putting stateful data in Kubernetes, that's what our company does. We also need to have a way to back up and restore that data now that we're storing it in Kubernetes. So we need a Kubernetes-aware backup product as well, and we have one of those as our second product. And then the third product is called Portworx Data Services. And it's a way for you to actually deploy managed databases in a Kubernetes cluster. So as opposed to having different Kubernetes managed services that you might use in like AWS or in Azure or on-prem, as long as you got a Kubernetes cluster, we can deploy managed databases for you from our portal. So that's the pitch for Portworx. That's really all we want to talk about what our product does. We really want to focus on what we did to build internal developer platforms so that we could get these products out to market faster. I thought it might be useful for us to have a little bit of a primer on what platform engineering is, just so we're all speaking kind of the same language here before we get into how we actually built it. So I've got a couple of cartoon character type slides here to give an explanation of the way things used to be and the way they are now. So before DevOps, a long time ago when I was a young system administrator and didn't have quite as many gray hairs in my beard, this is the way we deployed software. A developer was saying, hey, I've written some code. I'm ready to get this code pushed to production or maybe a development environment, something like that. They couldn't do this themselves. They needed help. And the help came from a set of system administrators. So they'd have to reach out to a system administrator who was normally used to deploying, storage arrays and setting up firewalls and servers and all the infrastructure type things. They would be the ones that actually deployed this software on those servers. And of course, the system administrator would say, sure, put in a ticket and we'll get to it, And there was a tacit eventually listed there at the end of that sentence, right? Eventually that software was going to get deployed, but you never really knew when. It just kind of depended on how busy the system administrator was. It wasn't great. We switched to DevOps. So DevOps model gave us the ability to have the developers deploy their own code, because at the same time DevOps was becoming more and more prevalent, we also had this other thing in the industry that was happening, which was public clouds started getting built, and they were used a lot. And that gave us an API to access our infrastructure. So that changed the way developers thought about code. Now they can say, look, I've got code ready to deploy. I'm just going to use the API and provision it on my own servers. I don't need to talk to that system administrator anymore. And this kind of came to a head when Werner Vogels famously said, you build it, you run it, right? So now the developers are able to build the code and run the code because they've got access to this API. They didn't have to talk to somebody else. So they started doing this. And the system administrators were still there, but they would say, look, hey, don't forget, you got to do all the corporate compliance stuff when you deploy your code, right? You've got availability to think about, disaster recovery. How are you managing costs? How are you monitoring your application? Did you have encryption for it? All of these things that the system administrators typically did to make sure that that code was secure and available. But now that responsibility had moved on to the developers because they were deploying and managing their own code. This got a little bit more tricky when, they had to do all of those things, but then they also had to learn the APIs and like how to provision these things in different environments. So Cloud 1, Cloud 2, Cloud 3. Now all of those things I had to learn before are just amplified because now I've got multiple environments to deploy things to. And the developers were basically like, this is a lot of stuff to remember on top of my main job, which is writing code. Now I have to also learn all these other things that typically the infrastructure teams did for you. It gets even worse when we've got lots of development teams. So imagine this scenario where we've got, 3 developers, in this case, we've got 3 different products that they're all deploying code for. Each one of those teams now has to learn all of this information, right? So we're pushing a lot of work up to the developers that they have to know and manage. And that's kind of where we got to platform engineering. So we still have our SMEs that are responsible for the infrastructure, things like the storage arrays and firewalls and servers. We still have our application developers who still want to be able to deploy their own code and manage that code. But we're giving them some help. So now we've got this layer in between them, and that's the platform engineering layer where our internal developer platform lives. And what we've done here is we basically bake in a lot of these capabilities into the IDP. So now the developers have a lower cognitive load, things they have to learn, things they have to keep up with. They just know that when they're ready to deploy code, they're going to use the IDP, and the IDP will deploy their infrastructure in the way that is best for the company around compliance standards and availability restrictions and disaster recovery, things that they need to take care of. That's kind of done for them. And we give them an easy way that they can deploy and manage their own code, right? So now the developer says, I've got code ready. I'm just going to use the IDP, provision my infrastructure according to our corporate standards, and you're kind of done. So that's the basic primer on platform engineering, how we got here. And now let's talk to the experts and just ask them some questions about how we built our own IDP. And I think to start this off, I want to ask the question to Rajan. What problems was Portworx trying to solve when we built our own IDP internally? Can you tell us what problems we were encountering and like what made us go down this path in the first place?
Great. First of all, great introduction to platform engineering, Eric. As you highlighted in your first slide, that Portworx is a line of products, right? And me being responsible and my team being responsible for delivering these products with high quality to our customers is of utmost importance to us, right? So let me kind of tell you the story. When I joined the team, we were having these 2-a-day calls. Sometimes they would run for an hour. One was really around understanding what difficulties our different engineering teams are having in terms of deploying and testing their code, whether it is the development team or whether it is the quality team. And the other one was really about getting an understanding of how ready are we to ship our products to production, either on our SaaS platform or building and shipping these container images that customers can deploy on-prem to configure and set up Portworx Enterprise. And not only that, the biggest pain point was discovered through a lot of interviews when I talked to these multiple development teams, and we're talking a team of more than 150 plus engineers. We had the tools, we had the mechanisms to get the job done, but as you showed in the DevOps model, these engineers had to know everything on what to do, where to go deploy things. And Portworx is any kind of an offering, which means Portworx can be deployed on any cloud, on any Kubernetes distribution, and on top of that, almost any Linux distribution. So you can imagine the plethora of combinations now one has to go through and understand how to configure these environments, how to set these things up, right? And that was a huge complexity for somebody who has just joined the team, for example. The other challenge was, before we released, right, our code to production, we always had this criteria, all of our pipeline jobs should be passing. And again, we are talking 100 plus jobs just to make one release happen, which was, again, a challenging thing for folks to manage and triage and understand where the failures are happening. Imagine scrolling through thousands of lines of Jenkins log files or other log files to figure out one thing that goes wrong, whether it could be in a deployment or whatnot. And last but not the least, we always want to ship very highly secure products, so our customers don't have to worry about security at all. And you touched upon that as well. We wanted to make sure we are always compliant, not only when we deliver the products, but when we are testing them in-house, whether in the public cloud or on-prem. And we had these tools and automation to do all this thing. But when I spoke to the engineers, their pain point was really around, hey, I really don't want to worry about this, right? I want the ability to be able to just write code, push it, and this platform or this, I want feedback on my code ASAP. I shouldn't have to worry about figuring out how many platforms or distributions I should go test my code on. How can you help me with that? When I spoke to the managers of the team or the leaders in the team, their main concern or the problem that they wanted to solve was, how do we get visibility on a day-to-day basis on what's happening with the products that we are trying to ship to our customers, the new features we are building? How are they going? How are they doing? How do we build predictability into our release model? So our sales team or product managers can go and give predictable dates to our customers, like, yep, you're going to get this feature by this time. Right. And we looked around, and what we really came up with, so what that told me was, we need this control center, right? Like, when you have these traffic management systems or, when you're running these large, like the Super Bowl is coming up, right? So you have this control center where you have information around almost everything that's happening during the game. And we imagined that, like, how can we bring all of this together so our developers do not have to leave that platform at any given point of time, from the time they stop writing code to the time it's pushed to production? How do we provide this ability to our leaders and the dev and QA managers to be able to get the pulse of how things are going in terms of the code, making it through the different stages of the pipeline? And while doing all of this, how do we stay compliant with the company's best practices around deploying secure codes and secure environments in public clouds as well as an on-prem. And we had a lot of on-prem infrastructure. So we wanted, we thought about like, why can't we provide a public cloud-like experience to our engineers as well? And that was the beginning of our journey where we thought of building this control center.
Awesome. Can you give us a little bit of a feel for the scale or the scope of this? Like how many, I know we talked about we have 3 main products, but how many teams are we supporting, or how many developers are we really supporting?
Yeah, so when I started with the team, we were 8 different teams. We were at 100 odd engineers. The team has grown to 150 plus engineers now. It was only 2 product offerings. Then we added Portworx Data Services, so that increased the complexity and the interoperability of what we need to build, ship, and test. It's a large initiative, as well as the scale is really about, as I mentioned, right, the complexity of the testing matrix. When you support any scale, any cloud, any distribution, we're talking like 50 plus kernels from these different whether it's Linux kernels or multiple Kubernetes distributions, and then any cloud.
Thank you. Appreciate that. That does make sense. Okay, so Charu, over to you. So we've got these problems internally with the way we develop software. What did we do to solve that? Can you walk us through this?
Cool. Thanks, Eric. Thanks, Rajan. So what prompted us to build this IDP? Before we even get started, as Rajan was saying, right, we started doing this interviews. We started talking to folks internally and try to understand what is the problem, right? And based on that, we came up with an expectation matrix. And the last thing we wanted to do was reinventing the wheel, right? So the challenges which were in front of us were like, make the on-prem infrastructure reliable, which is literally the foundation of everything we wanted to do, and reduce the burden for engineering teams of prolonged testbed deployment time, which involves 100 plus combinations of Linux distributions, on-prem, Kubernetes, other cloud platforms, and there comes different Portworx product as well, right? So there were too many combinations to support. And the next one was CI/CD, where engineers were spending a lot of time in triaging and debugging. And the last one, but not the least, is we wanted to help our team ship the product in the most secured way. That's where security scanning comes into picture, right? So based on these requirements, we started looking at some tools or solution out in the market. None of them were like tailored for our needs. There were solutions where which you gave high-level orchestrations and such, but we had to build that backend, or we had to build that intelligence and logic to make all these things, get all these things working. That is when we built an IDP for Portworx, a Portworx platform engineering innovation called Atos Studio. So going forward, wherever we say Atos, that means our, that's our IDP. Atos has multiple feathers in its hat. What you're seeing here in this slide, which talks about infrastructure, EAS, Atos stream pipelines, and security image scanning. These are some of the major ones which made like huge impact. Here is the first one, Atos Private Cloud. What was the problem here? Imagine this: you have 200 plus physical servers and more than 50 clusters with whatever virtualization technology you want to use, and all these things are being used by engineers in silo. And irrespective of their role, every engineer needed to understand the hardware and virtualization layer to get better output from them. And the worst, everyone needed to be aware of servers, clusters, networks, etc. they need to use, and they were literally using this information in their test to deploy, run the show. And not to forget the issue with over or underutilized hardware resources, because everything was in silo. We did not have a very good observability and monitoring in place. Everything looks chaotic, isn't it? So this prompted us to develop one of our foundational feature, Atos Private Cloud, and everything, we go with an API first mindset. So everything is API based, and we have a UI layer sitting on top of it. So what these APIs provides, so right from the cluster, from the place where we start the deployment, we help find the right cluster, the right hardware, depending upon whether you are a QA, dev, or marketing, which team you come from. We give you the right hardware to go ahead and do the deployment. And these APIs even provide rebalancing capabilities where, depending upon the hardware usages, it actually goes and picks up the right cluster where which has enough resources to go ahead and do the deployment. And the other thing, with these deployments are you need to stop. You need to know when to stop doing the deployments on these hardware resources or on these clusters, because what happens is if you cross a certain CPU memory or storage threshold, then you're not only jeopardizing the new deployments you're trying to do, you're actually hampering the one which are already running. Existing tests may also fail, right? So we have a mechanism, we have guardrails built where the ATOS private cloud APIs stop users from deploying on some of these clusters when they reach a certain threshold. And the last one is like lease and quota management. So this is really important. I'm going to talk about it more when I get into the demo slides. And today we are reaping the benefits of ATOS private cloud. We are doing efficient cluster rebalancing, enhanced pipeline stability. We have a very nice quota and release management. What is the impact which this has created, right? So we have drastically reduced cloud cost by left shifting some of the deployments to on-prem. So our on-prem is capable of running high performance test beds today. Because of that, we were able to run a lot of testing. We are able to do a lot of testing on-prem. And in FY24, we saved more than $1 million because of the benefits of private cloud. And our team today, a group of 150 engineers, as Rajan mentioned, and we run 9,000 high-performance virtual machines at any given point of time. That's where we are.
Yeah, just a quick question for you, Charu. In your first benefit, you said we saved $1 million, I think. Mm-hmm. You might have gone on to the next slide. I'm not sure. I was wondering where that cost savings predominantly came from. Is this from moving stuff on-prem? Is this doing it more efficiently on-prem, or is this based on those quotas? Like, where did that money come from?
So it is a combination of it is a combination of saving the resources based on lease and quota management, and also making sure that we use our hardware efficiently, so that there were some hardware which was not being used properly at all. So instead of going and buying this new hardware out from the market, we repurposed this and used it in a better way, and we made this direct saving of $1 million, which we would have ended up going buying new hardware.
Makes sense. Thank you.
Yeah, and to add to what Charu said, I definitely can agree to us not having the need to continue to buy more and more hardware because we are utilizing the existing one more efficiently. The other is, sometimes there was no need for us to go do high scale testing in the cloud. The only reason some of our teams are doing it was because they didn't have a reliable on-prem infrastructure, or so we were able to move such workloads on-prem once we had this better private cloud-like experience.
Makes sense. Thank you, Charu.
So the next one is ATOS environment as a service. The need of IDP was much more evident in this area. The whole engineering team, DevOps, QA, Dev, we were all literally spending a lot of time either in preparing the test beds or waiting for the test beds to be prepared. So we were dealing with a lot of complexity here, as I told earlier, right? Like 100 plus Linux OS kernels, combinations, multiple cloud platforms. And DevOps team were getting back-to-back requests, and a lot of them were getting queued as well. And we had another issue in our hands too, multiple infrastructure and automation frameworks, a lot of tribal knowledge, which no one wanted to remember and operate. So side effect of this, as any smart engineer would do, Dev and QA folks, they got approval from managers and they started moving to cloud for deploying these Kubernetes clusters and test beds, right? Because on-prem was not reliable and deployments used to take very long time because of this complex, some of the complex frameworks we had. And they thought, okay, it's okay to go ahead and deploy this in cloud. And the worst, using cloud resources for testing is not a bad idea, but keeping them over weekends, given the complexity of creating all these things, increased our cloud cost drastically. So that's when we came up with this solution, EAS. Today with ATOS EAS, we have the self-service model where everyone can come deploy the test beds on demand without any tickets, without any manual intervention. And of course, not to forget the different tribal knowledge of CLI options I spoke about. So we have the benefits of rapid testbed deployment today. We give a hybrid cloud experience. You can go ahead and use the portal to deploy these testbeds on-prem, cloud. We support multiple clouds here, and we have come up with an approval-based mechanism where anybody who wants to do a cloud deployment. See, what happens is with great power comes great responsibilities, right? So people had this one-click deployment of going and deploying in cloud. So everybody started doing this, then that will also impact in a negative way, right? So that's where we came up with an approval-based mechanism where for every cloud deployment, there is a message which goes to the manager. It probably take 10 seconds for the managers to look at the message and hit on a button so that the deployment will get approved and we go ahead and complete the deployment. This is just to make sure that the team manager and everybody is responsible and aware of what's going on, right? Coming to the impact, we have saved approximately 15,000 engineering hours in the last 8 months. That's when EAS was, went live. And we have eliminated the ticketing process. And today the DevOps team is spending time in new innovation and new initiatives rather than working on, creating the setup and such. And also with EAS and with the help of private cloud, we have reduced the cloud cost by more than 50% in FY24, compared to the previous years.
So it sounds like this is super useful for the application developers and things, but I have a question here, and maybe this is directed at Rajan. You've got all these developers that have already been using their own tools like Terraform or CI/CD pipelines or scripts or something to deploy their infrastructure. Did you have to do anything to force those developers to start using the IDP? Did they want to come to the IDP just because it was easier to use? And I'm also wondering if you had to do any prodding with leadership to get leadership buy-in to actually use an IDP or something like this. Maybe you can talk to how we got people to start embracing the IDP.
That's a great question, Eric. So, the answer is we had to do a little bit of all. First of all, once we did the interviews, we understood the user's journey, our developer's journey, and we used a very design thinking approach to build an empathy map. What are the pain points they have? So the first goal was to always build a better experience than what currently existed, right? And be able to showcase the value add of why then they don't have to use do the way they were doing earlier. We did a lot of road shows once we built the MVP, once we started, launching it, went to our alpha beta stages and collected a lot of feedback. So a lot of folks started adopting it. It started with some of the junior engineers because the senior engineers had their, as you mentioned, right? They have their way of doing things. They had their Terraform scripts. Everybody is always going to automate to reduce the manual overload. So we built a better experience, right? And then once we did the road shows, we showed it to the managers, and then we started pooling all these resources under this private cloud. So we shared with them the pain point of having these disaggregated resources, some underutilized, some overutilized, and they really understood, and they gave us a chance to allow to collate all the hardware that we had under this one umbrella. We provided them guaranteed resources. We also had dedicated resource for certain teams as well, where their entire team could go and use things. So the journey was really about building a better product at the end of the day for internal consumption. And we were tracking the metrics on who's using what, where folks are falling off. Like, we have a nice UI for our IDP. If folks are not using it enough, what are the pain points? And we opened up multiple forums for them to give feedback. And within the IDP itself, we have a 24/7 Slack support channel. Then we would of course, they could always file tickets on us to ask for more features over there.
Thank you. Appreciate that. Charlie, I'll let you get back to your presentation before I interrupted.
No problem. Thank you. So the next one is ATO stream pipelines. So one may think that we don't even need an IDP for running pipelines, right? We already have a lot of solution in market. And yes, we also use some of the solutions which is available in the market, right? But ADOS Orchestrator here is a game changer. So I'll give two examples here. One is the CI/CD pipeline orchestration. So we follow a step-by-step approach, which is designed to fail fast by left shifting the core functional or core test cases and running them as soon as a change gets into our repository, right? And this is to reduce the surface impact. So we don't want like 150 engineers running like 1,000 pipeline and they all failing for the same reason, right? That's the last thing we wanted. And ADOS Orchestrator helps build this recommendation logic where we have multiple stages, unit testing, and then the core functional and the functional test cases and the system test cases. So all these different stages, they flow from one stage to another only when there is a recommendation from the previous stage. So if you have a bug, if you have something in the previous stage, that change will not even be picked up for the next stage, right? And with the help of this model, our SaaS product, we do a release within like 4 to 5 hours at max. So once the change gets into our repository, within 5 hours of SaaS products, we are ready to ship it to our customers. So that's how efficient it is. And the mode of ADOS is like to make engineering teams' life easier, right? We wanted them to start debugging right from the browser. We don't wanted them to go ahead and log into the machine to see what's happening. And given that Portworx is a storage solution, we collect stats like network, storage, VM, CPU, memory, etc. Right? So this is very important for them to understand where the bottleneck is, why a test is failing, right? And all this information is available from the browser. They can take a look at it. They can correlate the error messages in the logs, and they can understand what's going on. So that's what we bring into the table. And the next one is unattended distro pipelines. This is something we are very excited about. Very recently we even finished this project. So think of this one, right? You have a lot of kernel versions, distro versions coming in which you need to support. And for every distro, we have a kernel pipeline, which is out in the market, which is coming in. There are new kernels which is coming in on a daily basis. So the requirement was, we had a team. The team's responsibility was to take a look at all the new distros coming in, take a look at all the new kernels which is coming in for every distros, and run pipelines on them and make sure that everything works, right? Today, with unattended distro pipeline, we have built an engine which will keep track of all these new kernels, all the new distributions, and it will publish to a dashboard on a daily basis. I'll show the dashboard in the next couple of minutes. And the next step was to build an orchestrator. For every kernel coming in, we have a pipeline which kicks in and runs the bare minimum test, which is required from the product side to make sure that this kernel, to validate Portworx on these kernels. So, and today we don't have the dedicated team doing that. They're doing better things today, right? Rather than babysitting the kernel versions and distro versions and running the pipelines, they just look at these failures only when they get their notification. If not, everything is unattended. Everything happens underneath.
So you're basically saying then that anytime a new Linux distribution comes out, our software is tested on it, and we know whether or not it works, probably before we knew that there was a new distribution that came out. Is that right?
Exactly. Yes.
Very cool.
Yeah. So that's one of the impact. As I told, we don't have that dedicated team, and it has enhanced the engineering productivity. And because of the CI/CD pipeline orchestrations we are doing, we have consolidated the pipelines, because one of the important thing is we need visibility on what's going on, right? So that's what these pipelines provide. We provide the capability of viewing all these things from one dashboard, from one place. I'll show that in the demo. So next one. Security, right? This was our next challenge. As every product, we had this responsibility of scanning, remediating, and shipping security images to our customers, right? And our customer, they own different registries, and they had different scanning tools. And also our compliance and governance team, they wanted us to track the SBOM for every release, like for all the Portworx products, which was literally manually impossible given that we do 25 releases per year and we use like 100 plus open source packages, right? And coming to our development team, poor guys, their requirement was very simple. They wanted a simplified process and a single pane of glass where they can see all the scanning results and eliminate the false positives and give fine-grained reports to point to them in the right direction. Because the problem with them was they were going and building this new product, new software, and there are multiple, as I told, our customers are using multiple registries, marketplace, multiple tools. They had to run this in multiple places, right? And again, we had a team. They were literally doing all this scanning, triaging, and remediation, and then giving a report to our developers and management. And it used to take 5 to 7 days. And again, this came with a lot of false positives as well, right? So that's where we ended up working on this solution. We embarked on this journey of automating this whole process and providing DevSecOps as a service. We use multiple industry standard tools which avoids false positive, and also providing the capability of viewing all these things from one place. Impact. Today we have the ability to perform on-demand scans, not just by the engineers. It can even the release management team, leaders, anybody can go ahead and do this 1 or 2 click scans, and this takes 30 minutes. This literally takes 30 minutes to complete instead of 5 to 7 days.
Yeah.
That's what we bring into the table.
Yeah, I'd like to add something here too, Eric, right? The reason we use multiple tools in-house is because, you can imagine, different companies, different, they all have their choice of tools, whether it's like a Palo Alto Networks or Lacework or Aquasec or cloud providers. And why they wouldn't even allow, downloading an image if a vulnerability is found in the image, even with a score of like 7 sometimes, right? So that was one thing. Now, the other challenge here was that once you run the scans from these tools are really good at telling you like, yeah, these are all the packages that have these vulnerabilities, but they're getting better. Some tell like, yep, these vulnerabilities are fixable because there's a community fix available on these open source packages. They still have these different scoring systems sometimes. One tool or one scanner will give a very critical score to the same package, whereas the other one would not. On top of that, the other challenge is how do you merge all of this information together and present it to the developer in a format where they can only work on what is critical to fix, right? That is, at the end of the day, that's one of the problems we were trying to solve. Like, we do not want the developers to spend time parsing these results and figuring out what is fixable, what's not fixable. And so I just wanted to share that, that's why it used to take such a long time, because it would go through multiple teams, first with a very small DevSecOps team who would be doing this job, then opening tickets, then going back and forth with the developers on, oh, well, yes, we can fix it, or no, why should we fix it? So we wanted to make that job easy, and then let the developers, again, not burn their brain cells, but just focus on what is critical to ship our products with high quality and security.
Makes sense. Thanks.
So let's get into the high-level design. So, Atos is not built for one team or product, right? So the philosophy here is we wanted to give a smartphone kind of experience to anybody who wants to use Atos, right? Like, you install app on top of your mobile and use it however you need. So we have built this platform where anyone can come and plug in their solution and then, get that uniform experience. If you see the first one, we are talking about the REST APIs here. So we have like 5 core microservices, which is running this beast of an application. We have the notification, observability, and scheduler layer as well integrated within. And irrespective of who you are, for example, you're from the security ops or DevOps, test automation, you are a team running some Jenkins pipelines, CD pipelines, whatever it is, right? We give that uniform experience here. And frameworks, you can bring or come and plug in your frameworks. So we have our own frameworks, which is written. We use some third-party frameworks as well. Everything is integrated, and we give that uniform experience for the engineers. So we have this beast of an application, right? And we need an equally majestic infrastructure to deploy and run these applications. So here in Portworx, we practice what we preach. And the whole Atos Studio, what you're seeing and what we just spoke about, everything runs on Portworx product. 100% of our DevOps internally use applications, whatever we have today, everything is deployed on top of our Portworx products. We have a DR dogfooding environment, which is built with Kubernetes, Red Hat, OpenShift, and Portworx storage solution. It's been a tremendous journey so far. I'll talk about the design. So if you see this design, you don't so there is I have heard a lot of people talking about this one, right? They say like, okay, if you want reliability, you need to go out and deploy things in cloud. If not, things will fail. You will not get consistent results. I disagree with that point. You need to know how to design the infrastructure and how to design your deployment architecture in the right way. So when you do that, you can get the similar kind of results in on-prem. So the stack, what I'm talking about, it is actually deployed on-prem. We have a source and a destination. We have a DR setup. We have a site A, site B. Both sites has Kubernetes clusters, and on top of it, we have Portworx stretch cluster, because we have both, stateful and stateless applications of ATOS running on top of it. And let me tell you this one. ATOS is a single point of failure for all the Portworx day-to-day operations. All our CI/CD pipelines, EAS, private cloud, everything, if they want to operate, ATOS is required. And we are running all these things and on top of it. And more than that, we do failover every month. We do, if not because of hardware, one of the server having issues, switch issues, failover, something like that, or if not, we induce failover and failure from site A to site B or site B to site A every month. And it's been more than 1.5 years, like easily 1.5 years we are running this, and we never had a downtime.
Yeah, so for our audience members that may be not familiar with Portworx, this is actually our flagship enterprise product. So in the slide you've got up with the deployment architecture, we've got 2 different Kubernetes clusters that are in different sites that are less than 10 milliseconds of round trip latency between them. And we're using a feature of our storage cluster that lives in the Kubernetes cluster called Portworx DR, or synchronous DR, where any writes written to your persistent volumes on one cluster are also written to another cluster, so that if you lose a node or you lose your entire cluster or your site, for example, you can just fail that over to another site. This is one of the things that we do with our software that we sell.
Cool. Thanks, Eric. Let me move on to the next slide. Stats and scale of operation. So, there were a couple of questions which Eric asked and Rajan was answering, right? Like, how is the adoption going? How is your team really using it, and all those things, right? What we believe is you can go out and build a world-class product. And if you don't have the right users, if you don't have people using it, it's meaningless. What is the use of such product which nobody uses, right? So if you take a look at this slide, we are a team of 150 engineers, and we deploy easily 6,000 virtual machines on a daily basis. At any given point of time, we have 9,000 virtual machines running, but 6,000 virtual machines, there is a churn rate. They get deployed, deleted on a daily basis. And that is possible because of the solid infrastructure we have and the solid private cloud APIs we have, which actually restricts and manages and deploys in an efficient manner. Per quarter, at any given point of time, we deploy like 50,000 test beds throughout the quarter, and which is equivalent to approximately 250,000 virtual machines. Cloud cost saving, as I told earlier, you can see the graph here. The cloud cost is going down as we started adopting EAS, private cloud, and other features, right? So, and we have typically 300 plus physical servers, which is supporting us at this point of time.
Yeah, what's most interesting to me is the 2 graphs, if you overlay them, right? The number of deployments are going up, but the costs are actually going down. So that seems like a win. Yeah,
for me, 150 seems like a small team, but you see, we do 1,000 deployments, 1,000 testbed deployment per day. And yeah, indeed, thanks for noticing it. Yeah, the chart goes down and the on-prem deployment is going up. That's where the reliability comes into picture.
Awesome. And can you show us it? Yep, there's the demo. Awesome. I love it.
Yeah. Let me take you to the demo. Just give me 1 second. Okay, I hope you are able to see my screen.
Looks good.
So, yeah, this is our portal, right? Anybody can come and they can, start deploying a testbed. The experience is very simple. Go ahead and click this button. You can select the product. and you can select what kind of platform you want to use, right? Whether it is on-prem, AWS, GK, AKS, whatever it is. And then let's say that I want to do setup and install Kubernetes and get Portworx installed on top of it, right? Everything, you don't have to change anything. But in case if you want to change, right, for example, the OS or the Kubernetes version, how many days you want, lease you want to keep, you can feel free to make those changes and just hit the deploy button. Depending upon what kind of deployment type you use, it will take 30 minutes to 1 hour to complete the deployment. For the benefit of this demo, I have picked up this example, which is the same, where we have the Kubernetes setup completed, right? So Atos makes it very easy and simple for anybody to come and manage their test beds. So it gives information about who deployed for what product, what branch we are using, all this information, right? And the most important thing is, if you go ahead and expand the testbed section, it gives information about what is this testbed, like how many virtual machines are there on this, what is the server cluster data center being used, and when it's going to expire, right? All this information. So this has Kubernetes installed, you have the kube config available. And let's say you want to extend the lease, you can hit this button and go ahead and extend the lease anytime you need. And you want to whitelist a testbed, you can whitelist a testbed. So why do we have this whitelist testbed feature is we have this long running test cases where we have the longevity team, they run tests for like 2 months, 3 months. We don't want to delete those testbeds. We want to keep the testbeds for a very long time. So we have given this capability for folks to go ahead and whitelist the testbed and keep for long time, so that our reapers, which is the lease and quota management as part of that, right? We have a reaper running. Those reaper ignore this whitelisted testbed. So the another part is tags. This is a very powerful feature of Atos. See, another philosophy is like, we don't want Atos to be a burden for anybody. We wanted it to be a boon. So all our frameworks are integrated such that we mine this information, we pull this data about what is the kind of deployment you have, what is the container runtime, what is the kernel version, and what is the Kubernetes version, all such things. So tomorrow, when the management comes to me and asks, like, can you give me a report of how many Kubernetes deployments you did, how many passed, how many failed, how many Portworx, what are the different Portworx we tested over the last 24 hours? We can go generate all such data within just click of a button. That's the power of Atos. So as I told, this is the stats where you can click on the stats. I'm not going to show it because it has some sensitive information with IP addresses and all. So when you click on it, you can see information about what is the VM, how they are looking, what is the MEM CPU used, and all those things for in-depth debugging. And Atos logs, here we do auto triaging and collect some logs, which will help folks in going and debugging the issues. So let's move on to the next one, which is the pipeline view. See, in this example, I've filtered for an engineer. So I just selected one engineer. They can come and see, and this is for L2 stage. So they have certain pipelines running. So this view makes it easier for the engineer. They can select number of days, 7 days, 30 days. They'll get a view of all their pipelines in one place. How many passed, how many failed, and we make it very easy. We have different legends. What we say is, if something has failed with infra error, don't even look at it. That's the responsibility of the DevOps team. If it has failed because of some other reason, we want them to triage it. You are seeing 2 colors here. That means that it has failed, but somebody has triaged the run. This is where it is very handy for the management to come and see how their team are, looking at the pipelines, whether they are really doing the triage, tracking the bugs. They get all this information from this view. And this is one more product we have, PDS, Portworx Data Services, and you can look at the pipeline here. Like, they run these pipelines on a daily basis, and you are seeing some red failures here. We don't, our motto is not to make this pipeline green all the time. Our motto is not to show green pipelines all the time. Our motto is to make sure that the changes are coming in and we catch the bugs as soon as possible. So the responsibility of the engineering team is to go and make sure that once the failure comes, go fix it and make it stable. That's what you're seeing here. Yeah, Rajan, you were about to say something.
Right. So I think I just wanted to add here, Eric, as I was saying earlier, right? This is the control center that serves those different personas and teams and engineers, all the way from your freshly joined engineer to the manager or the VP. it makes their job easy. You see the legend and all, right, where they don't have to even worry about triaging a failure if it falls into the category of installation or infrastructure issues. And this all came from the feedback, like, so that they can, from these engineers, so they have to spend less and less time in worrying about the infrastructure issues.
Yeah, I think I was originally expecting this to look a lot like a CI/CD pipeline, but it looks like we're doing all the things that you're doing after the deployment. That's super important for us, which is awesome. I love it.
Cool. I'll take another couple of minutes before we take the question and answers. So the next one is the private cloud. So this view, this is where folks, they can come and manage the test beds. We have a quota for how many test beds our engineer deploy as well. So we support only 4. At any given point of time, an engineer need more than 4 test beds. They have to delete the old ones and deploy new ones. This is to make sure that everybody gets an opportunity to go deploy the test beds as and when they need. And another important thing is, let's say my manager wants to see what's going on under his team, right? Like what is the number of deployments happening? They'll get the report as well. So if you see here under Rajan, we have 944 active test beds and approximately 4,400 VMs up and running. So this gives an understanding of how the team is doing depending upon the product, where they are using it. You can choose between different cloud as well, like where and all we are deploying, IBM, EKS, AKS, GKE, whatever it is. You can select and see how the deployments are going on. So there's a lot to cover. Okay. So this is a distro dashboard. This is what I was talking about. For every kernel, whenever there is a new kernel, the entry comes and sits here, and we automatically run. And whenever we find an issue, we block it, and we say something is failing, and the respective team will go ahead and check. And you click on it, you see information about, this is the data for the last 30 days. For this kernel, we ran this many times. It failed once because of some test error, and other times it has passed. So this is the view which the management uses to generate the reports. Yeah. So the last one is on the security. So this is what I was talking about. I have just opened an existing scan rather than starting a scan. This is the view our development team was asking, right? They were asking, I need a place where I can see all the scans which has happened, and I can see where it failed, where it passes. This is that one single pane of glass which we are providing, experience which we are providing for our engineers to go ahead and remediate the issue in an efficient way. Yeah. So let me get into the Q&A section.
Yeah. Awesome. Thank you so much for the demo. The product actually looks awesome. Maybe we should be selling it. I don't know. Want to switch over to some questions real quick. We've got a few questions in the queue already, and we got about 7 minutes to do it. So I'm just going to publish these to the screen, and I'm assuming either Charu or Rajan will answer these and not me. Published one to the screen. I don't know if I see it. I'll read it out loud. Is this full-grown platform, or are you using third-party or OSS products like Backstage? Also, observability is a main challenge for microservice-based applications. Do you have any of that in the portfolio?
So everything what we are developed here, right? We are not used any third-party software or anything. Everything is homegrown. We have used AngularJS for the UI, and we have used Python, and everything is a Python-based microservice. What was another question? Sorry.
So I think the question is, I can chime in too. Yes, the IDP is homegrown, right? But as we showed you the architecture, this IDP brings all the different components or services that are required to build and ship secure products with high quality together. Right? And you need an infrastructure to run it. And because we wanted to adopt a modern, platform, we chose Kubernetes, and then Portworx became the de facto choice for us because we have persistent or stateful applications where we need to store data and or logs. So it's a combination of all those things. For observability, we again use standard open source tools, Prometheus, Grafana, right? We we use the APIs for these different services to pass the metrics to that as well.
Yeah.
So another question that came in, one of the challenges identified in building an IDP is vendor lock-in. Besides diversifying architecture platforms, can using open source alternatives also make an impact?
Yeah, I mean, as Charu mentioned, right? We use open source components. We use open source components to build our IDP. I mean, we use one of the most famous programming languages, Python, to build these microservices. We are using the open source MongoDB, we are using the Portworx data services, but you can use any database, NoSQL, or even you can use SQL if you want. So it really depends on the use case and how far you want to take your IDP.
Yeah, and change is inevitable, right? Change is constant. So we, for example, we support some cloud deployments. Whenever there is a changes which is done on the cloud provider side, right, we have to go ahead and update our automation to make sure that things work. So that's a continuous process, and that'll happen always.
Yeah, one thing we didn't touch upon is we have a CI/CD for this IDP platform itself, right? Yeah. So we also have like a CI/CD pipeline or this 8.0 stream pipeline to test the IDP code itself. So we make sure that nothing is broken when our customers wake up in the morning and they're having their coffee and then just click on environment as a service, for example.
And I think you answered the next question, which is, what do you do when the provider makes a change? And I think we're saying there's always going to be change to the IDP. Someone's got to manage that. So you're going to have to keep up with those updates as well. Hopefully the cloud providers aren't changing things too often.
Yes, it happens though. We have seen backward compatibility breaking, right, in the APIs and all. And the best, we also use best software engineering practices there, where we have continuous unit testing, functional testing for our platform itself.
And the last question that came in from the audience was, do you use PVs or persistent volumes? And I'll answer that one. Of course we do. Yes, that's literally what our company was built to do, is help you deploy and manage your persistent volumes and provide those enterprise capabilities like replication, encryption, all of those things on top of that. So absolutely.
Yeah, and as Charu mentioned, right, one of the requirements that we came up with was we need to make sure we have zero downtime on this IDP because the impact of this being down is very high. You can imagine, even if we have a 30-minute downtime, we're talking almost 200 hours of lost productivity across the entire team. So that's why we used the synchronous DR or the Metro DR functionality of Portworx Enterprise, because these PVs and all, they are replicated in real time, and the failover happens within milliseconds. So there is zero impact to the developer at the end of the day in order to get their job done.
Awesome. Well, thank you guys both for your help with setting up this webinar and telling us about the IDP that you built. What might be more interesting to our audience is actually not how we use our IDP, but how some of our customers are using Portworx in their IDPs to do platform engineering. If you scan this QR code that's on the slide that's being showed currently, this takes you to a video of our general manager, Murley, talking to Ford about how they use platform engineering, and they're using our software underneath to help with that as well. So that might be interesting to the audience. Also, if you're looking for more information about Portworx and the types of things that we do, check out the IDC Spotlight. IDC just came out with their new analyst rankings of container data management, and you're going to see Pure and Portworx at the top of that list. But go and check that out if that might be interesting to you. Or go check out the blogs on our website. You can see some of the things I've written. Maybe you like those. I don't know. And then we've also got some demos on YouTube. So if you look for the Portworx channel on YouTube, there's a whole list of light boards and walkthroughs and all kinds of things about our products as well. So maybe that's also a bit interesting.